Okay, so today we're going to solve problems using annuities. And so this is Year 12 General Mathematics, Unit 4, Topic 1, Loans and Investments, and Subtopic 3, Annuities and Perpetuities. So what's the syllabus description that we are looking at today? So we are solving problems involving annuities, including perpetuities as a special case. So what is a perpetuity? It's a special kind of annuity where the amount of money invested to provide regular payments that continue on forever. So unlike a normal annuity where our balance will increase for a particular period of time or we take out payments for a particular period of time, a perpetuity continues forever. So scholarships and bursaries are examples of this perpetuity. So the special part of a perpetuity is that the investment amount remains the same. So that means that the interest that you earn on the money can never be more or less than the amount of money that is paid out of the fund. So they have to be equal. So we have a formula for working out the perpetuity. So A is the amount invested for an indefinite period of time, M is the amount of the regular payment, and I is the interest rate expressed as a decimal per period. So let's get to an example. So a wealthy businesswoman decides to set up a scholarship fund to assist a disadvantaged young person in her community. She invests in a perpetuity that is guaranteed an interest rate of 6% per annum. Determine the amount to be invested in this perpetuity to provide a regular monthly income of $500. So we know 6% per annum, but we need to work out it monthly. So let's write down the information we know. So interest rate, 6% as a decimal is 0.06. But it's compounding monthly, so the decimal monthly compounding period is 0.005. Our M value is $500 per month, and we need to work out how much money she needs to invest. So here's our formula. A equals M over I. 500 divided by 0.005. Get out my trusty calculator. So 500 over 0.005 equals $100,000. So $100,000. So let's write a statement. An investment of $100,000 is required to provide a regular monthly income of $500. Okay, let's do another example. Genevieve's grandparents set up a perpetuity to help her pay for her tertiary education. They invest $125,000 with an interest rate of 4.5% per annum, with this interest rate compounding quarterly. Calculate the amount of money that Genevieve can pay off her university fees. Okay, so our investment amount is going to be $125,000. Our interest rate is 4.5%, but we need to change this to a decimal and divide it by 4 because there are 4 compounding periods in a year. So let's put down what information we know. So 0.045 divided by 4 is 0.01125. We have to work out our M value, and we know our starting amount is $125,000. So 125,000 times, let's get out my trusty calculator, $125,000 times 0.01125 equals $1,406.25. So if we're looking for M, we need to multiply A by I. So next part of the question, her grandparents want Genevieve to receive $2,000 each quarter. And so they decide to shop around for a better investment rate. Calculate the interest rate that is needed every quarter to have a payment of $2,000. So now we're trying to find I. So we know our M is $2,000. Our amount is still the same as before, $125,000. So if we're looking for I, we put our hand over the I, and that gives us M divided by A. So that's 2,000 divided by 125,000. Bring up my trusty calculator. 2,000 divided by 125,000 equals 0.016. So that's 0.016% per period. So now we need to convert this to an annual percentage rate. So that means we have to multiply by 100 to turn it from a decimal into a percentage, and then multiply by 4 per compounding periods. So do that and I get 6.4%. So Genevieve's grandparents need an interest rate of 6.4% per annum compounding quarterly to give her a $2,000 per month payment. Okay, so now it's time for you to do some individual practice. So I need you to answer the questions in exercise 9.4 on page 316 of your textbook. And there are only a few questions for you to do. So questions 11, 12, 13, 14, and question 20. Then I want you to complete your study on Chapter 9, Concept 2. Once again, remember you need to end any previous session that you have started first before you start. Okay, so if you're watching the video now, you have completed all the questions from the textbook and your study on, and you are now checking your answers. Okay, so question 1 for concept 2 says an ex-student would like to provide an annual trophy for their former school by setting up an account which will pay for the trophy each year. If the annual interest rate is 3%, what is the minimum amount the ex-student should invest so that the $100 trophy can be bought in perpetuity? So how do we do this problem? Our interest rate is 3% per annum. Our payment amount is $100 and we have to work out A. So A equals M divided by I. 100 divided by 0.03 is $3,333.33. So our answer is D. Okay, let's move on to the next question. Question 2. A grandmother sets up an account for her first granddaughter so that she will receive $200 birthday present each year. If the grandmother invests $4,000, what is the minimum interest rate so that the granddaughter's present continues like forever? So let's write down the information that we know. We have to work out I. M is $200. A is 4,000. So we rearrange the equation to get 200 divided by 4,000, which is 0.05 per period. We need to convert that back to a percentage, and so we multiply by 100 and we get 5%. So our answer is A. Okay, so our next question, question 3. A benefactor left an amount of $115,000 to the local bowls club. The committee decides to invest the money at 6% per annum. What is the maximum amount the bowls club could receive annually if it is to remain at $115,000 in perpetuity? So once again, we write down the information we know. 6% as a decimal is 0.06. We have to work out M, and our A is $115,000. So by rearranging our equation, we know that M equals A times I, 115,000 times 0.06, $6,900. So our answer is B. Okay, question 4. An annual scholarship is paid out of a perpetuity of $40,000 invested at a rate of 6%. What is the value of the scholarship each year? Okay, what do we know? 6% is 0.06. We have to work out M. Our investment is $40,000. So rearranging our equation, M equals A times I, $40,000 times 0.06. So we get $2,400. So the scholarship is valued at $2,400 each year. Joel's grandparents decide that they will invest their money in a perpetuity to help their grandchildren's school and university fees. They invest their interest rate 3.5%, providing their grandchildren with a total of $2,345 per year. How much did they invest? Okay, so our interest rate is 3.5%, as expressed as a decimal is 0.035. Our payment amount is $2,345, and we have to work out A. So A equals M divided by I. $2,345 divided by 0.035, and that comes to $67,000. So Joel's grandparents invest $67,000 to provide a regular yearly income of $2,345.